Hey guys. Alright, so today we're going to be factoring binomials. And before we get started, let me just kind of back you up a little bit. This is what we spent time with last week or the week before. We spent time multiplying monomials to binomials, okay? And in order to do that, we multiply this times this first term, so 5x squared y times 3x, and then we multiply this times the second term, 5x squared y times 2y. Watch what we get. We get 5x squared y times 3x, so 5 times 3 is 15. X squared times x, well, there's a 1 there, so that's x cubed. 2 plus 1 is 3. And then there's a y times a y to a 0, so 1 plus 0 is still y to the first power, okay? And then plus 5x squared y times 2y, so that's 5 times 2 is 10. X squared times, well, there's no x there, so it's still just x squared. And then y times y, that's a 1 plus a 1, that's a y squared, okay? All right, so basically what we're going to be doing today is going backwards. We're going to go from this step back to this step, okay? What we're going to do is factor this binomial so that it looks like this. This right here is factored, okay? Anytime you have something times something else, those are factored terms, okay? So we're going to start with this binomial and we're going to go backwards and factor it. So what we have to do is ask ourselves, what was it basically that I multiplied to get this? You could also ask, what do these two terms have in common that I can divide out of it, okay? And so that's what we would be challenged with right now. So if you just look at the numbers, look at these guys, the coefficients, a 15 and a 10. What does a 15 and a 10 have in common? What's the biggest number that a 15 and 10 has in common? If you said 5, yeah, look, there's your 5 right there. Now look at the x's, the x cubed and the x squared. What's the biggest x that they have in common? Now some of you guys might be thinking, oh, the biggest x is x cubed, but I'm asking, what do they both have in common? What's the biggest x that they both can fit inside? Can an x cubed fit an x cubed? Sure, but can an x squared fit an x cubed in it? No. Okay, so basically you look here and say, what's the biggest x that I can divide out of this? And what's the biggest x that I can divide out of that they both have in common? Okay, so this guy has 3 x's multiplied together, so I could take up to 3 here. If I took up to 3 here, I would go over my limit. This guy has 2 x's multiplied together, so x times x. So the most I can divide out of this guy is x squared, or x and x. This guy here is the same thing. The most I could take out that has in common with that one is an x squared. So the biggest x that I could take out is an x squared, and that's what I have there. And finally here we have a y and we have a y squared. What's the biggest y that they have in common? Well, the biggest y that they have in common is just a y. I can take a y out of there, and I could take a y out of there. I could divide a y out of there, and I could divide a y out of there. Okay, so this is how you do it, working backwards. The biggest number that these guys had in common was a 5, so you put a 5 down. The biggest x that these two had in common was an x squared. The biggest y that those two had in common was a y. And then you ask yourself, okay, so 5x squared y times what gives me this? Well, you know, 5 times 3 gives you the 15, okay? X squared times what gives you x cubed? Well, that's x. And then y times what gives you y? Well, you don't need anything except times 1, right? So y times 1, you don't need to write it. So plus, now ask yourself, 5 times what gives you 10? That's 2. 5 times 2 is 10. X squared times what gives you x squared? We already have it, so you don't need to write anything. And then y times what gives you y squared? Y times y gives you y squared. So I factored it, done. And look, it looks exactly like this up here. See? They're exactly the same. That's how you're going to factor. Okay, so let's try a few examples. All right, here's our first example. 16 a cubed, okay, plus 8 a to the 5th b. Okay? All right, so ask yourself, what do these have in common that I can divide out? So let's look at the numbers first. There's a 16 and there's an 8. What's the biggest number that they have in common? Okay. All right, well, if you said 8, very good. If you said 4, that's great, but that's not the biggest. If you said 2, that's true, but it's not the biggest, okay? So I could take an 8 out of here, I could take an 8 out of here, so that's what I write down. Okay, I'm going to divide this by 8, I'm going to divide that by 8, okay? Now let's look at the A's. What's the biggest A that you can divide out? Okay, don't say A to the 5th. That's the biggest one that you see here, but what's the biggest one that you can divide out? That's an A cubed. Okay, so put down an A cubed. Okay, and now look at the B terms, okay? What's the biggest B that you can take out? Well, there's not a B here, so you can't take out a B at all. Okay? All right, so here we go. Ready? Put your parentheses. Now ask yourself, 8 times what gives you 16? That's 2. Okay, A cubed times what gives you A cubed? Well, times 1. So 2 times 1 is still just 2. Okay, so leave it. Plus, all right, 8 times what gives you 8? Okay, it's 1. Again, you don't need to write a 1. Okay. A cubed times what gives you A to the 5th? Well, you need 2 more of those A's multiplied together, right? So A squared, okay. And then we still have this times what gives me that B, so this times a B has to give me that B, okay? So there we go, and it's factored. This times this gives you this, and this times this gives you this. All right, let's do another one. 5v squared u squared plus 5v squared. Okay, here we go. All right, let's look at the 5s. What's the biggest that you could take out of both of them? What's the biggest number that a 5 has in common? This one and this one has in common with itself. That's right, a 5, so you put a 5 down, okay? Now look at the v's. There's a v squared here, there's a v squared here. What's the biggest v squared that I could divide out? Well, I could divide out a v, but I can divide out even bigger, v squared from here and v squared from here. Okay, so v squared, okay? Now look at the u squared. There's a u squared here, but there isn't one here. So what do they have in common? They don't have anything in common. You can't divide something out, okay? All right, so we've taken out everything we can. Now put the parentheses, all right? So 5 times what gives you 5? It's just a 1, so leave it. V squared times what gives you v squared? It's just a 1, so don't write it. And what times u squared gives you u squared? Well, you need u squared right here, okay? All right, so u squared times what? I'm sorry, it's a 1 times the u squared gives you u squared, okay? All right, plus, now it's 5 times what gives you 5? And it's, again, it's a 1, okay? V squared times what gives you v squared? It's a 1, okay? 1 times 1 is 1. Since there's nothing else going on here, I have to write the 1 in this case, okay? All right, so v squared, 5v squared times 1 gives you 5v squared, okay? It's kind of a confusing one, but hopefully you can use this example to help you out. All right, let's do something a little more challenging. All right, try this one. Let's try 36 x cubed y cubed, okay, minus 42 x to the 6th y to the 4th, okay? All right, here we go. 36 and 42, what do they have in common? I think they have a 6 in common, so I'll put a 6 down, okay? X cubed, x to the 6th. What's the biggest one you could take out? Well, x cubed, okay? Y cubed and y to the 4th, what's the biggest one you could take out? Y cubed, okay? All right, we're done. Put your parentheses. 6 times what gives you 36? 6 times 6. X cubed times what gives you x cubed? You don't need anything. Y cubed times what gives you y cubed? You don't need anything. All right, we're done there. Minus 6 times what gives you 42? 7, okay? All right. X cubed times what gives you x to the 6? Well, you need another x cubed. Okay, y cubed times what gives you y to the 4th? You need another y. Okay, there we go. All right, now let's do one that's a lot more scary looking, okay? Here we go. Example. All right, negative 49 a cubed b squared plus 14a squared plus 21. And this looks crazy. All right, look at all these numbers. What do they all have in common? Okay, I think 7, so we could put a 7 here. Okay, all right. Here's an a cubed, here's an a squared, but there isn't an a here, so they don't all have an a in common, so let that one go. Okay, here's a b squared here, there's not a b here, there's not a b here. They don't all have a b in common, so let that one go. Okay, all right, so watch this. We're done. We got the 7. So 7 times what gives you negative 49? Well, that's a negative 7, okay? And we still need times a cubed b squared, a cubed b squared to get that a cubed b squared, okay? And then 7, and then plus 7 times what gives you 14? That's a 2, okay? All right, and then 7 times 2 is 14. So we still need an a squared here. So a squared, so 7 times 2a squared is 14a squared, okay? And then plus 7 times what is 21? That's a 3. Now, there is an issue with this problem. Typically, inside the parentheses, we're not going to start a trinomial with a negative sign. So here's what you're going to do, okay? And if you don't do this, whatever, nobody's going to take off points on a test, but it's just not completely factored, okay? It is factored. You factored out the biggest, monomial factor right there, okay? But we really should get rid of that 7. So watch this. I'm going to take the 7 out. I'm going to put it in front, so negative 7, okay? And then this, if this is a negative 7, right, then if that's a negative 7, then doesn't that become a positive 7? So positive 7, a cubed b squared, okay? And then if I took the negative out of here, basically I took the negative out of here, right? So this sign will change. Watch, isn't negative 7 times negative 2a squared? Isn't that positive 14a squared? So basically, if you take the negative out of here, you change all the signs. Okay, so this guy right here was a positive, now it's going to be a negative. Okay, so now if you notice, I divided out a negative 1 from all of these guys. I put it out in the front, and then I just changed the signs for all of those guys. Okay, let's do one last example. Let's do this. Negative, and you'll see, here's another example just like it, okay? So negative 60 u to the 8th v, okay, minus 10 u v to the 3rd plus 40 u v squared. Okay? All right, give that one a shot. All right, here we go. Look at this. There's a 60, a 10, and a 40. What do they all have in common? Well, if they all end in 0, then you could say a 10, right? So I'm going to put a 10 here, okay? All right, and then here's a u to the 8th. Here's a u, here's a u. What's the biggest u that I can take out of all those? All right, it's just a u. All right, and here's a v cubed, and here's a v squared. What's the biggest v that I could take out? Well, that's the biggest one right there, so a v, okay? All right, so here we go. 10 times what gives you negative 60? That's negative 6. U times what gives you u to the 8th? Well, u to the 7th. V times what gives you v? You don't need anything, so just times 1, so just leave it, okay? All right. 10 times what gives you negative 10? So that's negative 1, so you can put negative 1 if you want. Okay, you don't have to put that 1 right there. U times what gives you u? Okay, well, we got the u times 1 gives you u. And then v times what gives you v cubed? We need a v squared. Okay, so that's a negative 1v squared. Okay, and then finally, 10 times what gives you 40? So plus 4. And then u times what gives you u? You already have the u, so it's just times 1, so you don't need to write it. And then v times what gives you v squared? That's a v. All right, but again, we have that negative here. So let's put the negative out in front, so negative 10uv, okay? And inside, let's switch all the signs. So this is positive 6u to the 7th. That's a positive 1v squared, so I'm just going to put v squared instead of 1v squared. And then that is going to switch to negative, so minus 4v. Okie doke. All right, guys, good luck. I'll talk to you soon.